If you tried to protect your smartphone from cyber threats using a copy-pasted security update from 1995, the system would instantly crash. And yet, in modern agriculture, we've done something very similar to this. Over the last 50 years, we've optimized our US corn on a very efficient but very closed biological operating system. We've been shuffling the same genetics over and over again in order to specialize in one specific environment, the US Corn Belt. But as climate change has introduced more unpredictable weather and new pests, these are basically the biological equivalents of new malware, our corn needs more adaptability to survive, just as a security update would keep your phone running even when it's exposed to threats. To bring back more adaptability to our corn, we don't need to rewrite the entire genetic code from scratch. We just need to do what software developers do, push a targeted update. Luckily, this update already exists in the form of diverse tropical corn. This tropical corn has the exact natural defense genes that our US lines lack, which includes defenses against heat stress, drought tolerance, pest resistance, and a more optimized nutrient uptake. But there is a major problem. Tropical corn is used to growing under 12 to 13 hour day lengths, and when you try to plant it in the US, where we can experience day lengths of 15 hours or more in the summer, the long days confuse the internal clock of the corn and cause it to flower too late in the season to produce grain. In order to get these natural defense genes from tropical corn into the US corn, we need tropical varieties that will grow early and flower early under long day length conditions. My research focuses on solving this day length problem. I've analyzed the network of genes that control this internal clock, and from the 70 genes in the network, I've identified 4 to 5 candidate genes that, when edited, would neutralize this day length problem in tropical varieties. These edits would basically act like a lightweight software patch. They would disable the late flowering of the tropical varieties and leave the beneficial defense genes intact. This solution would allow breeders to rapidly download decades of these natural defense genes directly into the crops that feed the world. Corn breeding has been hugely successful over the past century thanks to the incredible genetic diversity available. To face future threats, we don't need to rewrite the entire genetic code from scratch. We just need to bring in the right genes.